Fifth reaction we are going to see is Carbil amine reaction. Now in this reaction, when primary amines are treated with chloroform, that is CaCl3, and alcoholic potassium hydroxide. When primary amine is heated with chloroform and alcoholic potassium hydroxide, then formation of bad smelling or foul smelling alkyl or aryl isocyanide, or it is also named as Carbil amine. This test is given by only primary amines. Secondary and tertiary amines does not undergo this reaction. Now how this reaction takes place? Look here. When this primary amine is heated with chloroform and alcoholic KOH, then here breaking of this NH bond takes place. Then here this KCl is removed and this hydrogen atom and this H2O is removed, that is 2 hydrogen atom from amine, 1 hydrogen atom from chloroform and 3 OH group from KOH are removed as a thrice H2O. This K get attached to this Cl and this Rn get attached to this carbon atom to form RNC plus 3 molecules of H2O plus 3 molecules of KCl. This is alkyl isocyanide. Aromatic amines like aniline also react with this chloroform and alcoholic potassium hydroxide to give phenyl isocyanide. Now here this is alkyl isocyanide. The smell of this is bad or foul smell. This test is not given by secondary and tertiary amine. Now this is the example. This is aniline, that is C6H5NH2. When this aniline is treated with chloroform and potassium hydroxide in alcoholic medium, when this reaction mixture is heated, then you will get here C6H5NC plus 3 molecules of H2O plus 3 molecules of KCl. This is phenyl isocyanide. This is aniline is also primary amine. Therefore, it undergoes this Carbil amine test to give phenyl isocyanide having foul smell. Next reaction, that is 6th number reaction, is reaction with nitrous acid, that is HNO2. Now this nitrous acid or HNO2 is unstable reagent and therefore it is prepared at the time of reaction. Now here primary, secondary and tertiary amines react differently with this nitrous acid. This nitrous acid is unstable reagent. Therefore it is prepared at the time of reaction in reaction mixture. This is sodium nitrite. When this sodium aqueous solution of sodium nitrite is treated with concentrated HCl, then here formation of HNO2 takes place and removal of NaCl takes place. This is HNO2 plus NaCl. Now this reaction is carried out along with primary amine. Now we are going to see first reaction, that is reaction of nitrous acid with aliphatic primary amine. Now here it is RNH2, that is primary amine. When this primary amine is treated with nitrous acid in presence of this concentrated HCl and sodium nitrite, then this reaction is carried out at 0 degrees Celsius to 5 degrees Celsius temperature or 273 Kelvin to 278 Kelvin temperature. That is, during this reaction, the reaction mixture must have lower temperature. Then here, this primary amine undergo diazotization reaction to form Rn 2 positive Cl minus. This is alkyl diazonium chloride. This salt is obtained plus H2O. Two molecules of H2O are formed. This compound is alkyl diazonium chloride. This alkyl diazonium chloride readily undergo hydrolysis in presence of water molecule to give ROH plus N2 plus HCl. Formation of alcohol takes place. Next reaction we are going to see, that is aromatic primary amine. When aromatic primary amine undergo reaction with nitrous acid in presence of this sodium nitrite and concentrated HCl at 273 Kelvin to 278 Kelvin, then here this aniline undergo diazotization reaction to give phenyl diazonium chloride plus 2H2O. This is phenyl diazonium chloride. This phenyl diazonium chloride or aryl diazonium chloride or this salt is a stable salt which can be stabilized by resonance. That is, this resonance stabilization of aryl diazonium salt can be shown here. This aryl diazonium salt can be stabilized by resonance like this. This electron pair is shifted on this nitrogen atom and these pi electrons of benzene ring are shifted in between this carbon and nitrogen atom to form next resonating structure. Here there is positive charge, here nitrogen, here double bond, and now it becomes negatively charged. Now here this electron pair gets shifted in between these two carbon atom to form next resonating structure like this. Then again these electron pairs or pi electrons get shifted in between these two carbon atom. Then we'll get next resonating structure. At ortho position there is positive charge, double bond N, negative. Then again this electron pair gets shifted and this electron pair gets shifted to form next resonating structure like this. That is, this is the first structure. This 5 resonating structure stabilizes the aryl diazonium salt, and therefore this aryl diazonium salt is a stable compound or stable intermediate which is used to prepare various types of organic compounds. Now we have seen that when aniline is treated with nitrous acid in presence of sodium nitrite and concentrated HCl at 273 to 278 Kelvin temperature gives benzene diazonium chloride or aryl diazonium salt. Benzene diazonium chloride is nothing but aryl diazonium salt. Now this aryl diazonium salt or this C6H5N2X is undergo various types of nucleophilic substitution reaction with various types of nucleophile to give various types of product. Therefore, this is good intermediate to produce variety of chemicals. Now here this aryl diazonium chloride possesses N2 positive X minus group, which is a good living group, and therefore this nucleophile is substituted by another nucleophile to form variety of products. Now we are going to see the reaction of this aryl diazonium salt, in which first reaction we are going to see reactions involving displacement of diazo group. Now this diazo group, that is N2 plus group, is a good living group and which can be replaced by another nucleophile, and therefore variety of products are formed. Now first reaction we are going to see Sandmeyer's reaction. Now this Sandmeyer's reaction we have seen in halogen derivatives also. Now here this is aryl diazonium chloride, that is C6H5 N2X. Here N2 carries positive charge and X carries negative charge. This is salt. Now when this compound is treated with cuprous chloride, that is CuCl plus HCl, then here formation of chlorobenzene takes place. That is this N2X is replaced by Cl plus N2 is removed. This is the chlorobenzene, that is formation of this haloarine, that is chlorobenzene takes place. Now in second reaction, when this aryl diazonium halide is treated with cuprous bromide, that is CuBr, in presence of HBr, then you will get aryl bromide or bromobenzene plus N2. Now if this aryl diazonium halide is treated with cuprous cyanide or CuCN plus HCN, then this N2 is replaced by CN group to give this aryl cyanide or cyanobenzene plus N2. In this way we can prepare chlorobenzene, bromobenzene or cyanobenzene by Sandmeyer's reaction using aryl diazonium halide. Now second reaction, Gattermann reaction. Now in Gattermann reaction, when this aryl diazonium halide is treated with copper in presence of HCl, then this N2 is replaced by this chlorine to give chlorobenzene or aryl chloride. Cl plus N2 plus HX. This is chlorobenzene is formed. Now this aryl diazonium halide, when treated with copper in presence of HBr, then here you will get bromobenzene, that is this N2 is replaced by bromine to give bromobenzene plus N2 plus HX. Now here also by using Gattermann reaction we will get haloarines, that is chlorobenzene or bromobenzene. Then formation of iodoarine or iodobenzene. Now in this case, when this aryl diazonium halide is treated with Ki, then we will get iodobenzene plus N2 plus Kx. That is this I is replaced by this X and this I get replaced by this N2 to give iodobenzene. Then mild reduction of this aryl diazonium halide. Now this aryl diazonium halide undergo mild reduction into benzene using this H3PO2 followed by hydrolysis, that is H2O or in presence of H2O, to form here this is benzene, that is C6H6 is formed plus N2 plus H3PO3. Formation of H3PO3 takes place. Now next, when this aryl diazonium halide undergo reduction or mild reduction in presence of ethanol gives benzene. Plus N2. Now here this ethanol is used for the reduction of this aryl diazonium halide, therefore it undergo oxidation to give CH3 C double bond OH, that is acetaldehyde. In this way, this aryl diazonium halide undergo mild reduction to give benzene. Now next, 5 number reaction, phenol formation. Now this reaction we have seen in the preparation of phenol. When this diazonium halide, that is aryl diazonium halide, undergo hydrolysis at 283 Kelvin temperature, you will get phenol. In this way, this aryl diazonium salt is useful reagent for the preparation of haloarenes, then for the preparation of benzene, when it undergo mild reduction gives benzene, and when this aryl diazonium halide undergo hydrolysis gives phenol. Next chemical property of this aryl diazonium halide is reaction with fluoroboric acid, that is HbF4. This is fluoroboric acid. Now here this aryl diazonium halide, when it is treated with HbF4 or fluoroboric acid, then here formation of aryl diazonium fluoroborate takes place, that is N2BF4. That is, this halogen atom is replaced by this BF4 and this hydrogen get attached to this X to form HX. This is aryl diazonium fluoroborate. Now this aryl diazonium fluoroborate undergo two types of changes, in which first change, this aryl diazonium fluoroborate, when it is strongly heated, then will get fluoroarene. That is, this N2 is completely, that is N2BF4 is completely replaced by fluorine to form fluoroarene. Plus N2 plus BF3. Now this aryl diazonium fluoroborate, when it is heated with copper in presence of aqueous sodium nitrite, then here we'll get nitroarene. This N2BF4 is replaced by NO2 group to give nitroarene plus N2 plus BF3. In this way, this aryl diazonium halide, when treated with fluoroboric acid, gives aryl diazonium fluoroborate. This aryl diazonium fluoroborate, when strongly heated, gives fluoroarene, and when this aryl diazonium fluoroborate is heated with copper in presence of aqueous sodium nitrate, gives nitroarenes. Now we are going to see next reaction, that is reaction involving retention of diazo group. That is second type of reaction of aryl diazonium halide, that is reaction involving retention of diazo group. In this reaction, azo group, that is N2 group, is not removed. This reaction is named as coupling reaction, or it is also named as azo coupling. Now here, when benzene diazonium chloride is treated with any aromatic compound like phenol or aniline, then here for it undergo azo coupling to give colored compounds. Now here, first example, when this benzene diazonium chloride is treated with phenol in presence of alkaline medium, then it undergo electrophilic aromatic substitution reaction. This is electrophilic aromatic substitution reaction in which this N2 plus acts as a electrophile, and this electrophilic aromatic substitution reaction takes place para position of aromatic compound, either it is phenol or aniline. Now here, when this benzene diazonium chloride undergo reaction with phenol in presence of alkaline medium, then here hydrogen atom from para position of phenol is replaced by this N2 group or diazo, benzene diazo group to form this compound plus HCl. Name of this compound is para-hydroxy azobenzene. This is orange color dye. That is, when these benzene diazonium chloride undergo coupling with any aromatic compound, it gives colored dyes or dark colored dyes. Now here it is orange dye. This para-hydroxyazobenzene is an orange dye. Now here this benzene diazonium chloride, when it is treated with aniline, that is C6H5NH2 in presence of alkaline medium, then here also this hydrogen atom is replaced by this N2 group to form para-amino azobenzene, which is yellow color dye. When this benzene diazonium chloride undergo coupling with any aromatic compound, it formed dyes, that is colored compounds.
Homework for you. Complete the following reactions. This is next homework. Complete both homework in your notebook. Make PDF of it and submit this homework on Google Classroom. Thank you.